I'm here to talk to you and to give you more or less, I would say, a less technical talk. So my goal here is really to give you a different perspective on how a strategy is developed for a company, for a startup in this case, regarding technology. And we will touch base on our journey and how we use Django for that. So let me try to get you excited on that, and let's see how this journey come across, and hopefully it gets you ideas on how to do that on your own, for your company, as you wish. So basically, I will start with one topic that is give you a brief overview of our Portuguese tech ecosystem. So this conference is still in Portugal in a way. So I'll give you just a brief overview. Then we'll go, and it's just also a brief overview on the Django as a go-to framework and how it is established today. And most importantly, we will go through our case. So Hub's case, how we are using Django, but not only. So it's a little bit about our technology, about our strategic approaches to technology, I would say. And so hopefully get you some insights. Looking at the Portuguese ecosystem, first of all, talking a little bit about the startup ecosystem. From 2000 upwards, there are three main waves of startups. We have startups that are already unicorns like Farfetch. We have, and I'm talking about the early 2000s, until the crisis, mostly of 2008. Afterwards, in 2011, 2012, we have new startups coming in, like Unbaba, like Codacy. And in 2015, more or less around that year, we have a third wave where companies like Hub, like InfraSpeak were created. Nowadays, we have a new wave coming in, not quite sure, and we will still lacking some examples. As you know, with these first years are hard for startups. Another important aspect, we've been hosting main tech events. Let's consider Web Summit a tech event in a way, and we've been having these tech events showing that Portugal is a hub for technology. DjangoCon is again another example, and we've been having a lot of investment from big tech companies like Revolut, like Google, like different companies that come across and are basically looking for talent here in Portugal. Some numbers also to give you a better idea. So we have 30 companies in the 500 fastest growing companies in the EMEA region. One of them it's us, Hub. We can see the growth in Portuguese startups from 2015 upwards. And especially we are very well placed in terms of global innovation index, but especially concerning talent competitiveness. So we are a hub for talent, and it's recognized across Europe already. And so this is something very exciting for us in these times where technology is clearly the enabler for a lot of business models. And we have a very strong education foundations here. So it's great in terms of talent and the talent that we find here in Portugal. Looking at Django, and just, well, probably everyone knows about it, but just to touch base very quickly, Django is being used and it's getting popular, I would say, and I like their own description, or the community own description on the framework itself. So it brings scalable solutions, but with deadlines in a way. So it's really for innovative companies that want to give and to have pace, sometimes compromising in some ways some performance standards, but we'll get to it. But especially, it's really a very innovative framework, I would say, for companies that are looking to bring new features to the customers with consistency. And we can see that, well, it was created around 2003, and we can see that it's getting its own attraction in sectors like science and education, computers, electronics, and there are different companies, big companies with giant data transactions using it, like Pinterest, Instagram, not only Django, but also Django. So it's a proof that it can be scalable until certain points. And we get to the point where we will look at our case. Looking at our case, and first of all, I need you to understand a little bit better what is Hub, what we do mostly, because it is required for me to explain afterwards our path and our journey and why did we take the decisions that we took in the past. And so explaining a little bit, and I will be as brief as I can with explanations, but mostly at Hub, what we do is manage the supply chain of fashion brands. And so we have this platform that gives the end-to-end visibility and traction of all the physical flow of goods, and also consequently the data flow of their goods. And so we are really working from their production sites in China, in India, in Northern Africa, until the end delivery. This end delivery could be around the world. We are delivering for more than 130 countries already. So it's really a global supply chain that we are managing, and we are giving and making available the infrastructure for the brands to use. And this infrastructure is not ours, it's a partner-based infrastructure. So we use partners like 3PL, so third-party logistics that own warehouses like Maersk, like Agility. We use transportation companies like UPS, DHL, FedEx, and we also integrate with other solutions like online stores, marketplaces. And the goal is really to be able to give the full digital experience to the brand from their production sites, from the moment that the production is ready in their factories or in their suppliers' factories, until one of you buys in a store or in online or e-commerce shop. So it's really this end-to-end solution and omni-channel solution too, because we are managing all the sales channels of the brands. Another positive aspect to it is that as we are so as we integrate so much vertically all of these processes, we control the data. So we are not ingesting a lot of data from outside sources that we don't control. When we need these outside sources is in very controlled processes that we are managing actively. So we get all the data basically from the supply chain of a brand. We use a global partner network. So as I was referring to, we have a lot of different partners that we use today. And another important aspect to it is really we use this logistics as a service business model. And you have to, I have to give you that context that in logistics, everything is very transactional based. And we are bringing this logistics as a service business model, a proxy for the software as a service. And let me give you a proxy for you to understand it better. Well, logistics is really, well, I pick up the product in point A, I deliver it in point B. What we want to bring to the table is really, okay, but we don't need to think that way anymore. We can think in a management perspective, in a more complex and in a holistic perspective of the supply chain. And so give you an example is exactly as us Hub, we use a platform like Amazon Web Services, where we have most of our servers or machines, and so we don't have that much physical machines anymore, physical servers. We are using this platform to really have this digital access to this infrastructure. At the same way, we are building this to the brands. Instead of using like data warehouses, we are using physical warehouses, but the idea is the same. So they have access to an infrastructure, and they have a full 100% digital solution for them to overcome the obstacles of the physical flow of goods across the world. That is something that is quite complex. And so in the end, we get to this proxy where we are the platform that provides all of this infrastructure to the brand, and the brand focus itself in their product development, in their sales, and we will be managing all the rest. Well, we have the overview, so hopefully you get a clear picture of what we do. And now let me try to introduce you a little bit the path and the decision-making process. A lot of dimensions that are that are related with technology. So starting with it, and I have here a before Django, but it's not just before, it's really the beginning for us of using Django internally. So before Django, we had a monolith solution. Really, it was for quick prototyping, MVP development, and as all the startups, really in the beginning, you want to get your product as soon as possible to the market. And we use different solutions there, but mainly we get to a point where we have a monolith, but with a lot of constraints in terms of performance. And so in that sense, and then in that moment, we start to wondering, what can we do? Should we start breaking it down already? And how, and what decision, what bounded context should we look at? And so before doing that, our decision was to build one new monolith in a way, but a more structured one, and that was basically extending the one that we had already. So we call this our core API, and was built with Django. And the idea was, and because at that moment we were thinking about service-oriented architectures, we were not yet in like microservices, because we didn't have a clear picture of these contexts and the complexity to manage all the flow of information. And so we started to really with this monolith again, but instead of being just a monolith, what we did was start with a Django project with several apps internally that were more or less our approach to a service-oriented architecture in a way, because what we did was we break it down to the order management system that has all the information about the orders, about the purchase orders to the suppliers. We had the delivery management system that had all the information about the deliveries to the end customers. We have inventory management systems, all the information about stock levels, about the management of the stock itself. We had an app for what we call the master data. There was a product catalog, was customers, was all the more statical information, let's say it. And so in some way, we were starting to break things up a bit, but still, it was the same project, same code base. So it wasn't really separated in that sense. And another important thing was we were using the same data infrastructure. So basically, the persistency was still completely coupled. And so we were not getting too much of, I would say, of benefit in terms of development cycle and speed, but at least we have a more performant framework for our main processes. And that was really the goal at that moment was really to guarantee that we had a framework that could help us getting more performance, because the data was growing and growing substantially at this moment. Another example that I want to give you, at this moment, we started to integrate a lot of different partners, as I stated earlier. And the most complex ones were definitely the warehouses. So there's a lot of complexity, a lot of specific processes that we needed to integrate with our partners, and especially the integration layer. They are quite complex when we are looking at this detailed view of the data. And so we needed to ensure that a good mapping and a solid integration layer. We needed to handle authentication. We needed to guarantee all the business logic for these operational procedures, and also everything that was related to data validations. And so to do this, we created a new Django project, and we started to build what we call our 3PL, third-party logistics API. It was a new project with a new data structure. So we were finally separating some context, but still, this was something newer. And so it wasn't really a breakdown of what we had so far. It was a new development on top of what we had, but it was a new project indeed, and an extension of our business model with an orientation for a specific service. And so the main idea, and what I want you to get as a high-level picture at this moment is really this before Django, or beginning of our usage of Django is, and I think for everyone it happens a bit like this. It's not a clear path. It's really a bumpy road where you are testing out, you are taking decisions, you are making a lot of things happening, but you are not completely confident of the way, and that's all right. You need to get a lot of insight and a lot of knowledge before taking decisions like, well, this is my architecture that I should choose. This is the framework, the go-to framework for me, or this is the way that I should shape my architecture. So there's a lot of complexity in that decision making. But the idea was, well, we get to a point where we could really integrate our partners using this new service, and guaranteeing that we had our core systems, they have their own, and there was this layer in the middle that has also a lot of business logic to perform the processes. And there were different processes. We had the fulfillment in the warehousing, the shipping process in the warehousing. We have stock transfer from our warehouses to their warehouses, stock visibility and management. But the main idea here is that you get to a point where the complexity starts to increase. And so we needed more services. We started to build more services, and you start to get a lot of limitations from this solution in a way, because with the usage of more services, you actually start to need an API gateway. And with that, you get to some problems like the increased complexity on the routing, data translation, aggregation. So there's a lot of complexity that started to arise at this moment, and we needed to take care of that. So this is the before and the beginning of Django for us. And the advantage that I see, and putting myself at that moment, was really the community, the very active community that our developers could use for our benefit and contribute in their way too. So that's a great thing for a framework. The support for API development in terms of the usage, and we use a lot, obviously, the Django REST framework, the very, very good documentation. So Django was born from a newspaper. I don't know if that's why, but the documentation is very good, very clear, and the good ORM also that was critical for us, especially in the beginning where we had this massive database to really work on. So the ORM is very intuitive in that sense, and easy to tweak common features. What we used as a company mostly was the framework, but also the ORM, I was saying, with Postgres, and the REST framework, because we were very focused on API development. And now we get to another point in our journey. So we were mostly working with this framework, and the challenges that we were having were based on the complexity of everything that was around. And so we needed to adopt, I would say, a different perspective. And in terms of that different perspective, we started to look at and understanding what are our bounded contexts. Can we break down more than just this service, high-level service perspective? Can we go deeper than that? And how can we do that? And how can we understand what is a bounded context for us and how can we use it? And so we started to look at this distribution event-driven architecture, and this was the point where we started to really break down the monolith. And this is, I think, for all companies, a hard journey, a very time-consuming journey, but it's really what gives us the power to scale. And so we started to break it and especially guarantee that these are completely decoupled services that we are bringing to the table. And so organize the solutions around this bounded context is absolutely important, guaranteeing that we have the data segregation that we, as I told you, we didn't have at this moment, just for like new services, but mostly the data was still absolutely coupled. And the main goals were really to improve scalability, performance, manageability, because every time we needed to maintain some of these code bases, the complexity was extremely high, and extensibility. So we needed more features, new things to come up, and we needed capacity to do that. And there was a lot of complexity for us to achieve that. And so for the new services, when we decided to start breaking down this monolith, we finally had the ability and the capacity to work really this full stack approach. Is really from the data to the business logic to the application layer. And so we start with, and it was our first approach like this. It was like a code first approach with Django migrations. We wanted to, and we could finally define everything from start. We start to use signals too, really to start decoupling our API actions from everything that was related with domain, with the data layer, with the events, with the commands that were being generated. And these events and commands were being generated by our message broker that we started to use back then. That was Kafka, to guarantee that all the different bounded contexts were communicating asynchronously between them. And so we started to be much more, I would say, pragmatic in terms of the approach. Especially, we start to have much smaller scopes to develop things. So we start to have smaller scopes in terms of requirements, in terms of what we wanted to develop, what features we want to bring to the product, and the development itself got much easier and much faster. And again, I think that is one of the advantages of the Django framework here, is really the reliability with speed for development. So you can bring innovation to the product without compromising that much reliability and efficiency. And so Obviously, all the companies need to understand within this triangle, how are you positioning yourself? But we want to bring innovation, so we need something that we can act upon quickly, and Django brought that to us. We also started at this moment to build our own packages, our own wrappers on top of the DRF, things like HTTP helpers, authentication handlings. We start to build on top of Kafka tool for producing, consuming events, a boilerplate for that. And we will see that we use that in more than just the software development. We will get to it. And event logging, a lot of different things, and so we start to extend a lot of features, and we created our own environment, I would say. You see here that the journey now continues with this product-driven perspective, and then we have the data-driven, the AI-driven, and now we'll try to give you this perspective and somehow correlate with how we think about architecture, about technology, about the frameworks that we use. In terms of the product-driven, we get to a point then, after all of this change, our product and especially our architecture changed completely, and we got to this point. So we got to the point where we have a bounded context clearly defined, like the inventory management, delivery management, tracking experience, order management, all of these clearly defined bounded context. And inside of each bounded context, you have a lot of different microservices. And obviously, inside of each bounded context, they can communicate with REST outside. Everything has to pass through Kafka. So basically, with commands or events, everything has to go through our message broker. And that's the definition for, at least for us, of a well-defined microservice architecture and a distributed one in that perspective. And so you can see that it's much more organized. We now know much better what are our contexts, where is the complexity, because these contexts are highly correlated with the business complexity, or at least at the entities, business entities that are being managed inside of each bounded context. And so we get to this point where we have a much clear picture of what we were building. In terms of our tech stack, as you can see, we are pretty straightforward. So we use Kafka for the messaging. We use, as for databases, Postgres mainly. We also use MongoDB for smaller services. We use for the backend Django and Nest, mostly for our gateways, and in the front end we use Angular. So pretty straightforward, and I don't think that you need to be very you need to be very agnostic in a way, so to be able to not get too stuck inside of a framework or a language, but you need also some sort of specialization to guarantee that you are and you have the capacity and the competencies to develop with highly innovative pace, and at the same time with reliability and efficiency again. And now, to try to correlate this and this software development with other characteristics that we believe that are critical for a company. And the journey for a company, and you know that, you see that everywhere, all the companies are now or data-driven or AI-driven. And at least I will give you my view, our view of what does this mean. I have an article on Medium that I go deeper on this. But the idea, when you are a product-driven company, you are basically solving all your problems with new features. So we are focusing on delivering new features to the customer, and you need to be innovative to do that, and also have pace on your development to really deliver that value to the customer. When you are data-driven, you are absolutely obsessed with ingesting all the data that you can to be able to take better decisions. But these decisions are not easy to extract from the data. So you have these data lakes or whatever, and you have a lot of tools on top of it, and especially a lot of people, also data analysts, extracting knowledge from this data and helping you take the decisions or themselves taking the decisions on how to do, what to do next, what is the next step. And so this data-driven, and I want also to give you another interesting perspective of using Django and Python in this case, is that we can basically work, and we have three main tech teams. That is the software development, the data engineering, and the AI team, and all of them work with Python. So there's already some interesting matches in terms of the in common place in terms of all the teams, and I'll get to some of the other interesting aspects to it. But first, just to give you this idea of what does this mean, this data platform architecture that I'm showing you here, is we have on the left our source systems, and when we are this data-driven company, we want to ingest all of this information from our legacy systems, our monolith or whatever, and this is much more query-based in a way. Then we have our new services, and we want to plug this architecture that we saw earlier here. That's why you see that the orchestrator that we have in the middle is basically developed by us. It is custom made, and we develop it with Python to guarantee that we can consume the events as another service is consuming the events or commands being generated by one service. We can also consume them here, and using the same packages that we extended and I talked to you earlier about. And so there's already conjugancy in terms of what we are using. Again, the teams are much more close, connected, interconnected, and working together in that sense, because every time a change is made in the software, we need to replicate immediately here, because it is our source of the data that we are ingesting, and also about all the products that we use internally, being Slack, HubSpot, People, Google Analytics, whatever. All these products, we are also ingesting all of this information. And this information serves the purpose of our analysts that you see on the right, this report layer, but also serves the purpose of our models, our algorithms. And so this is, I would say, the next step. And here, your main focus, as I was saying earlier, is really you want to deliver and to solve problems using as much data as you can to be able to rely and get a much more fundamented answer to that problem. And the opposite effect is that you get in here, we had a lot of analysts extracting knowledge from the data, and that is, I would say, the reverse side of the coin, is there is much data to be analyzed. And finally, we get to a point where we want to become, and this is a path and a long path that we are also doing right now, and is becoming this AI-driven company. And the AI-driven company, the logic here is really that you want to solve all your problems, or most of your problems, with a model of the world, a model of what's called a small world, whatever, is really replicate this understanding of the world that you can perceive from the data that you've been collecting, understand what is the generative process behind it, and try to take the best decision possible about this and using that data. Obviously, this is not easy, it's extremely complex. And I will try to get you our idea of how can we do this, not just at scale, but in a controlled environment. Because it's not just about deploying models and doing things with machine learning, it's about how can you really encapsulate all of this inside of your architectures, the things that we've been defining until this moment and so far. How can we correlate all of this? And so this AI driven, it starts with a definition of what are the problems that you are facing. And for us, I believe this is pretty straightforward. It's not one of those very it is complex afterwards, but to define it is not so complex. So we have four main, let's call problems that we want to solve here. That is, we need to understand what will happen in the future. So this sales forecasting, what will be the sales of our brands in the future, because we need that information to take actions earlier in time. And then we have this supply chain optimization model that's nothing more than using all the nodes on our network and understand, well, I have a package that needs to pass through all of these nodes. What is the best path for that package specifically? And so we need to define that. And to define that, we need to estimate its capacity. Node 1, what is the capacity for that node? For node 2, for node 3? And also we need to understand that there are always disruptions. In our case, could be because a package is stuck in customs in the US, and it happens several times. And can we do something about it? And can we earlier in time do something about it? And so it's really about all of these problems and how to solve all of these problems. And again, we get to the same point where we were. We have different problems, different contexts in a way. And in using, in this type of film, or we're focusing now in terms of optimization or prediction or whatever, this kind of models, there are even more complexity to add here. Because if I solve these problems with, and you see here that we are looking at a solution that is oriented with microservices too. Also for machine learning, that's something strange, but it is the way for us to do the same that we did earlier. We have some logic of the world. Can we break it down to simpler logics? We can. The hard part here is that when you start to break them down, probably you will sub-optimize the main problem that you are facing. So if I'm breaking down one problem and trying to solve it in 4 different steps, if I guarantee that I'm 100% optimal in step 1, 2, 3, 4, probably I'm not being optimal in the problem overall. I'm being suboptimal on those problems. And so one of the things is really to have this end-to-end visibility and optimization. We need to understand in the end of each overall process, what are our results? It's not just about the specific model, it's about the overall problem that we are solving. We need to be agnostic in terms of technology and field of approach, because you can see that we use deep learning, machine learning, heuristics, whatever, because these are different problems, need different engines to solve it, and we need it to be scalable. Another thing that is very important to us regarding these models is really, we want them to take actions. These are not just decision-making support systems. These are actually models that take actions. And this means, and you can see that that will and the executing word there is because we want them to explicitly take actions on our product that is spoke on this different services. And let's see, how can we do this? First of all, we will get to a point where these 4 main topics will become I don't know, tens of different microservices too, in a way, micro models, if you want. And so we get to the same place. Okay, we have a lot of different models. How can we guarantee that all of this makes sense? And how can we guarantee that these are in the where they are needed at each time step? And so one thing that we did was basically, okay, we already have the bounded context defined. Can we use this bounded context as the bounded context for each of these micro models that we are defining? Well, we can. And so what you see here is that we are basically adding these micro models to each bounded context that we have. So for the inventory management, for delivery management, those blue and green squares are actually micro models that are being used and that are interconnected with the microservices, the software microservices, and giving and taking actions for themselves. I will show you an example, but the clear picture here is they are very, very close to what is a microservice. Obviously, there's absolutely different logic internally. Another thing that is different, they don't persist data, they just receive data, they compute data, and then they will trigger results, and these results will impact the state of a microservice that will receive that result. And that is the overall idea. And so if we look at an example here, for instance, let's imagine a new event that came in, a new sales order was created. You see those brown squares there vertically. This new sales order is going downwards. And you see that at each time step, we probably need some kind of decision that could be taken by an analyst or whatever. But right now, it is taken in that specific bounded context by each of one of these services. So if you see the delivery management is asking that specific service, O2FC, for the fulfillment center, the best node in the network for that order. Afterwards, we need to get the estimation on the product levels, volumes and weights, and what is the best pack set. So what is the best, what are the best packs for me to pack that order, best box combinations to pack that order. Why? Because we want the best pack set that optimizes our pricing, so our costs. So we will look at all of our options with our different transport companies, and we want the best one. And as you can see, we are again using the data platform for the models to get their information, and they are not persisting any information, but they are answering back to these services with their decision making that they got to after their computation. And so this will basically trigger a state change inside of a microservice, and potentially it will impact the overall decision. So if we could use UPS, but in this order, it makes more sense to use FedEx because of this pack set combination. And the idea is really that you have this environment that is built, that it has this end-to-end scope. It is domain-driven in a way, so we are not trying to solve problems here and we have the software here and everything is disconnected. We are trying to combine things, and we all know what are we solving at each new feature that we bring to the customer or to the product. This is dynamic data, and it's agnostic again in terms of technology and in terms of field of approach. And to start wrapping up with some of the ideas, we get to this microservice architecture, and I'm just giving you a brief overview of what this means in a different perspective. But the main idea is loosely coupled, isolated, persistency. So now we have all the data specific that we need at each bounded context in each microservice. A shared source of the truth. It's event driven, so it's really asynchronous, and we can rely on that to get performance. and it's domain-driven and follows the domain-driven design, which is for us absolutely critical because of the complexity of all these entities that we can find in logistics. That is very, 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 very detail driven, and so there's a lot of small things that interact with other small things, and it's really easy for you to lose yourself in the middle of all of this. Before finishing, I want also to give you an idea of what is the impact of all of this in the final customer, in the final user of the product. And I have here an example. So we have this tracking system, and the tracking system is nothing more than the same approach that, for instance, DHL has. And so when you buy online and you receive those emails stating that, well, your order will arrive soon or has arrived or whatever, it is that tracking system of orders and that specific perspective. But the difference here is that, first of all, we are using several different carriers, so tens of different carriers. So we need to unify all of their approaches and standardize all of those approaches. We are using some carriers that don't have this service, and they are probably cheaper. They have different tech infrastructure, whatever, and so we deploy this service that uses deep learning to classify this tracking status based on everything that was communicated, and mostly in a standardized way. So we have to control what are the different classifications possible, different classes possible. And based on that, we don't want to solve this problem with just a new feature to the brand, as I was saying. So we want to solve it with our model. And so what our model triggers in the end is not just an insight of, well, it wasn't delivered, it has had a disruption of somehow, but we get a notification sent or for the final customer or for the brand or for us with the detail of what has to be done next to guarantee that this order is delivered. And in red, you can see an example for end customer like you, if you buy on one of our brands, and if the order has some missing information, for instance, the address on your side, and we need you to contact the carrier, this is a message that you will receive. On the other hand, if it is on our side, for instance, we were the ones notified saying it is on hold, we will take care of this for you, and we on our end will receive this, it is on hold, please take this action, send this documentation, whatever. And the idea here is that the model is basically taking the heavy decision making of the process, the heavy tree-based decision making of the process, and in the end, it doesn't matter if it's us, the customer, or the brand, everyone is basically being notified of exactly what to do next. And so there's a lot of features that we could bring to the product here that we don't need to, because they are already sorted out. They are already decided at this moment in time. And so in the end, this is how, on our perspective, you start to solve problems using machine learning, deep learning, whatever, is really taking the decisions out of the way and avoiding having to build features for someone to take the decisions or for someone to take actions. It's really about notifying when we really need to be notified and with what we need to do, basically. To close, in our next steps, we need to continue our re-architecture process. As I would say, every company in the world, we are always reinventing ourselves in a way. Again, we need to keep breaking this monolith and splitting this microservice event-driven architecture, continue to do this splitting, And we need to invest more in asynchronous like approaches. And here this will be important for more performant services. And you also need to always be aware of that and understand what are your core services that will need definitely a different approach because of their size, because of on that perspective could be because of the number of actions taken, or could be because of the query consumption of the data for that service specifically, and you start using different approaches like CQRS or whatever. And so there's always a need to evolve, but especially you need to define very well what are your core services and what will you do about those core services in the future, while you keep the pace of innovation, bringing more services, more features, more ideas to the table and to your end customer. Thank you.